Hey everybody, so in this video we are going to be solving trigonometric equations. So here it says solve 6 sine of 2 theta plus 9 of sine theta if it equals 0. And they want us to find all the solutions from 0 to 2 pi. So when I'm solving equations, the first thing I have to do is reduce as much as I can. Here, this sine of 2 theta, this can be reduced. So what I'm going to do is I'm going to use a double angle identity for sine. So here I'm going to bring down the 6, and sine of 2 theta, this is equal to 2 sine theta cosine theta. And then what I'll do is I'll just finish and I'll bring down the rest. So this is going to be plus 9 sine theta equals 0. Now I'll solve this just like I would any other algebra equation. So I'm going to distribute the 6 here, and that's going to give me 12 sine theta cosine theta plus 9 sine theta, and this equals 0. Here, this is a binomial, and there's only 2 ways to factor a binomial. You can use difference of squares or greatest common factor. Since this is a plus, difference of squares is pretty much out the window. So we're going to pull out the greatest common factor here. So I have a 12 and a 9. That greatest common factor is 3, and this term has a sine, and so does this one. So I'm going to factor out 3 sine theta. And that's going to leave me with 4 cosine theta plus 3, and this is going to be equal to 0. Now that this is factored, I'm going to set each of these equal to 0. So I have 3 sine theta equal to 0, and I'll have 4 cosine theta plus 3 equal to 0. Now I'll need to solve each here. So this will be sine of theta equals 0, because 0 divided by 3 is 0. And then here, this is going to be cosine theta equals negative 3 over 4. Now, evaluating these is going to be pretty easy. Sine theta equals 0. So here with this domain, we're essentially looking at the unit circle. So where on the unit circle do I have y values that are 0? And that is at 0, pi, and 2 pi. Now, notice here, I have 0, pi, and 2 pi. Look at my domain. You see how this says less than or equal to, and this one just says less than? So this means a solution can be 0, but cannot be 2 pi. So 2 pi does not fit within this domain. So here, I'm not going to include it as part of my solutions. Now, this one's a little bit different. So we're going to have to think about this one. This says cosine theta equals negative 3 over 4. Well, negative 3 over 4 is not a value on the unit circle. So how would I find the radian here? Well, we want theta by itself. So I need to think, okay, how do I undo this function of cosine? Well, the way we undo functions is by multiplying them by their inverse. So here, theta would be the inverse cosine of negative 3 over 4. Now, this you're going to have a calculator for. Since your domain is in radians, you're going to want your calculator to be in radians for this as well. If my domain were in degrees, I would want my calculator in degrees. So I'm going to say inverse cosine of negative 3 over 4, and that's going to give me 2.42. So here, theta is 2.42. Now this is an odd solution because we're used to seeing these because they're from the unit circle. We're not really used to seeing something like 2.42, right? But we can still think about it like a radian. So here, let's construct a unit circle. All right, and on the unit circle, we know we have pi halves and pi. We also know that inverse cosine can only come from quadrants 1 and 2, so there's really no need to say that this is 3 pi halves. The value's not going to be there. We need to know 2.42, where is this? Like if that were a radian, is that radian in quadrant 1 or quadrant 2? We need to decide that. So since this is a decimal, we can make each of these decimals. Well, everybody kind of knows that pi is just 3.14. We can find the value of pi halves. So I could say pi halves divided by, pi divided by 2 is 1.57. So this is 1.57 and this is 3.14. 2.42 would have to fall in the second quadrant. So it really doesn't matter where we put it. We just know it's going to be somewhere right in here. Now, one thing that I want you to grasp during this video, 2.42 is not the x value. 2.42 is the radian. Now, remember, radians is like a distance. So imagine if I started here and walked this distance. I've walked or traveled 2.42 radians. So don't think of this as an x value, because if you do, you'll try to make this negative, and that's not right. Now, we know that x values are the same here, and they're the same on a vertical line. So if I brought a straight line right here, these x values are going to be the same. 2.42, like I said, is the radian, so that's the distance you walked. Okay, so this x value, this horizontal distance from the y-axis, is going to be the same here, and it's going to be the exact same right here. So I need to figure out, what is this radian? Well, the easiest way to think about this is I could say 2 pi minus 2.42. Which intuitively, this kind of makes sense, because if I start here and I walk 2.42 radians, I could do the same thing here. I could start here and walk backwards. But you have to think, if I've gone all the way around the unit circle, I'm here at 2 pi. So if I'm at 2 pi and walk backwards to get to this place, that would tell me how many radians it is starting from 0. So here I can say 2 pi minus 2.42, and that gives me 3.86. So here you have 4 solutions: 0, pi, 2.42, and I have 3.86. So these would be my 4 solutions. All right, that's going to be all for this video. I hope that you found it helpful. If you have any questions, please leave them in the comments, and we'll see you all in the next video.